Right now, you're sitting somewhere that feels solid and still, but rewind the clock far enough, and the ground beneath you was a boiling sea of lava, radiating heat at 8,500 degrees Celsius. Fast forward, and that same spot was buried under miles of solid, blinding ice, a frozen state that lasted for millions of years. We perceive our planet as a permanent, peaceful sanctuary. In reality, Earth's history is a relentless cycle of extreme violence and planetary collisions. Human life is not the product of a gentle evolutionary path. We are here because of a sequence of devastating, near-total apocalypses. These cataclysmic resets acted as the engine that forced life to exist and evolve. 4.5 billion years ago, the early Earth was a toxic wasteland. Then it was struck by a Mars-sized planet named Theia. The debris from this collision fused together to form our moon. This new mass permanently stabilized Earth's gravitational orbit and locked its axis in place. This new gravitational pull acted as a magnet, drawing in violent asteroid bombardments. These asteroids carried a critical payload: salt, minerals, and frozen water that melted to form our oceans. The most violent planetary collision in our history provided the physical architecture for a habitable world. The first microscopic life emerged from underwater volcanoes. These organisms survived by breathing out a gas that was, at the time, a new addition to the environment: oxygen. As this oxygen flooded the planet, it reacted with the iron in the rocks and water. The entire planet effectively rusted, turning the landscape deep red, much like the surface of Mars today. This spike in oxygen destroyed the early greenhouse effect. Without that insulation, the entire planet plummeted into a freezing, apocalyptic state known as Snowball Earth. Only the heat from deep Earth volcanoes prevented the freeze from becoming permanent, eventually melting the ice after millions of years. The microbes that survived began using that surplus of oxygen to power larger, multicellular bodies. Over the hundreds of millions of years that followed, this jump in available energy allowed for the rise of massive forests and the first animals to walk on land. This first mass extinction provided the shift in chemistry required to force life from microscopic cells into complex ecosystems. For ages, giant reptiles utterly dominated a lush, fragmented Earth. Their success left no room for other species to rise or diversify. That dominance ended when a massive 4.5 trillion kilo asteroid struck the planet at 80,000 kilometers per hour. The impact equaled the energy of 100 million nuclear bombs. Life near the impact zone was vaporized instantly, while a shroud of ash covered the rest of the globe. This dust blocked the sun, triggering a rapid ice age. The cold-blooded dinosaurs, unable to regulate their heat or find food, were starved out. Our tiny mammalian ancestors only survived this apocalypse by hiding in burrows deep underground. Massive destruction from space was the event that cleared the evolutionary board, allowing mammals, and eventually humans, to inherit the planet. Human evolution was driven by a final, smaller reset. In Africa, lush jungles dried out into harsh, barren landscapes. Losing their trees forced early apes to walk upright to find food. This transition directly led to the use of tools and the birth of human civilization. While nature takes millions of years to alter the atmosphere, we are now pumping the air full of CO2 in a tiny fraction of that time. This graph tracks historical CO2 levels. Note how the highest peaks align with the planet's major mass extinctions. Our current emission rate is now climbing vertically, replicating the conditions that triggered previous resets. We are functioning as the next massive asteroid. Earth has survived lava, acid, and ice by drastically resetting itself. It will survive us too, but we may not be part of what comes next.